1. All right, so for this one, for the law of cosines, they give you 3 sides instead of 2 sides and an angle. So let me rewrite our law of cosines equation again. Law of cosines. So earlier I gave you c squared is equal to a squared plus b squared minus 2ab cosine of c. So this time we are going to be asked to solve for an angle. Let me try and zoom out to show you. See how it says find the measure of q to the nearest tenth of a degree. So in this section we are learning to solve for the angle. So I'm going to rearrange this equation so that we can solve for cosine c. Okay, or solve for the angle c. So if we were trying to get cosine c all by itself, what I would do would be subtract a squared and b squared on both sides. So then you would get c squared minus a squared minus b squared equals negative 2ab cosine c. And then cosine c is still not by itself, so I want to divide it by negative 2ab so that those can cancel out. So divide by negative 2ab. And then that would give you, well, I'll just have to rewrite it, c squared minus a squared minus b squared over negative 2ab, which would be cosine c. And then what we can do here is inverse cosine. Zoom out a little bit. So if we do the cosine inverse of this entire thing, that would give us the degree c. Okay, so then even if you don't write down all of this stuff, I want you to write this one, because I already gave you this first one. This is the first equation. If you just manipulate the equation and rewrite it, you will get the second equation, which will help you solve for it. That way you don't have to do this work every single time. So I'm giving you guys the second equation just so we can plug it in. So I'll give you guys some time to write that. Then let's zoom out. I mean, if you still need to write it down, it's right over there. And let's take a look at the problem. Okay, so in triangle PQR, I'm going to draw my triangle over here this time. PQR. We have little p is 36 centimeters, little q is 21 centimeters, and little r is 17 centimeters. And we want to find the measure of angle Q to the nearest tenth of a degree. So that means our C that we are looking for, the angle that we are looking for, we're going to replace that with Q, okay? So Q, instead of C, is going to be equal to little q, oops, sorry, I need to write cosine inverse. So I'm rewriting this equation right over here. So angle Q is going to be equal to the cosine inverse of little q squared minus p squared minus r squared over negative 2pr. Okay, so I just rewrote this equation with the letters PQR, where the one that we are looking for, the angle we are looking for, which is Q, gets to be the C. So we are looking for Q, so that's what I put as C. And everything else just kind of falls into place. Okay, any questions on the rewriting it? If you do, interrupt me, please. And other than that, let's plug everything in so we know what we're typing on the calculator. So our angle Q is going to be equal to the cosine inverse of little q squared, so that's this one, 21 squared minus p squared, that's this one, 36 squared, I want to put them in parentheses, minus r squared, that's this one, 17 squared, all over negative 2, and then the p, once again, is 36, and the r is 17. So all of that goes in the cosine inverse. So I just plugged it in. Are there any questions up till here? Please let me know, and I'll also give you guys time to write. Calculator out, delete all of that. All of it. Is there a faster way to do that? Okay, so we're going to do cosine inverse, and then we're going to type that giant chunk of a thing. 21 squared. I think I'm going to put the fraction here first so that I could type like that. Okay, 21 squared minus 36 squared minus 17 squared, and then put that all over the negative 2 times 36 times 17. Okay, so this was the equation that we had said we would type in. You're double checking that I wrote it correctly? Yes. All right, so the nearest tenth of a degree of 20.82, that means we want 20.8. Are there any questions up till here? Okay. Once again, you can always feel free to tell me to go backwards because I never know how much I'm lagging and I can't read your facial expressions. So just let me know. Okay, let's do the next problem. Screenshot that. Okay, so instead of rewriting that entire series of equations on the top this time, I'm just going to write the final equation that we would use. So C is equal to cosine inverse of little c squared minus little a squared minus little b squared all over negative 2 little a little b. So the angle that we were looking for is C in this equation, and here's the equation that we are using. Then we have a triangle STU where little s is 5.9, little t is 1.9, and little u is 6.2. Not drawn to scale, obviously. Find the measure of angle t to the nearest tenth of a degree. So angle t is going to be our C, okay? And S and U can be A and B. But angle t is going to be our C when we rewrite our equation. So let's rewrite this thing so that we know what we're plugging in and where. So we're looking for angle t, so that's going to be equal to cosine inverse of little t squared minus s squared minus u squared all over negative 2 su. So here's our equation, and we're going to plug stuff into that equation. Any questions on it before I start plugging in? Okay, so let's plug everything in. So t is equal to cosine inverse of little t squared, that's the 1.9, so 1.9 squared, minus little s squared, so that's 5.9, minus little u squared, that's 6.2, all over, I'm going to write it here just because I have space, negative 2, 5.9, and u is 6.2. I just wrote it over there because I didn't want to write over the words. So it looks a little weird, but that's where it is. Any questions on this before I go ahead and type it in? Alrighty. Remember, once again, if you do have questions, let me know. Oh, I didn't see if anyone needed more time. Okay, I guess not. Let's type this in. Okay. Oops. So much to type, sorry. Okay. 1.9 squared minus 5 point, oh my gosh, 5.9 squared minus 6.2 squared all over -2 times 5.9 times 6.2. Okay, did I type that right? Yes. Okay, so 17.845, and we want it to the nearest tenth of a degree, so that's 17.8. Okay. And then I'm going to submit the answer. And yeah,